In this example, we are going to solve a very interesting problem, and that is how can we create a class that can model a deck of playing cards. This time we will do something a little bit different than other times when we're introducing a problem. So I will give you the problem description, but then I will spend quite some time into describing the solution, or one possible solution. If you want, you can pause the video right after the problem description without seeing the hints and try to solve it on your own. And then, as you need, if you need it, gradually see how we have chosen to model the solution in this problem. The specific features that we want the class to have are the following. We want to be able to draw cards at random from our deck. What does that mean, to draw a card at random? For example, it could mean that we have a method that will be called draw, and it will return an integer, and that integer will be representing a card. So it will return to us the number that is associated with a particular card. We also want to be able to shuffle the deck. We may have an integer associated with a particular card, as we said with the draw card method, but then we also want to have a way to convert this card number, the card representation, whatever that is, it may be a number or whatever else you may want to have, to the suit and the value string of the playing card. Finally, we would also like to be able to deal a hand of 5 cards and determine if it is a flush. If you're not familiar with poker, you can look up what exactly a flush is. How will we represent cards in this particular solution that we will discuss? Again, feel free to pause the video here and try your own implementation without seeing any hints. We have chosen to represent suits as integers from 0 to 3. So hearts we will represent with 0, spades with 1, diamonds with 2, clubs with 3. This is a very simple mapping from symbol to a number. Then we can do the same thing for the card values. So the ace will be 0, we will represent 2 with 1, 3 with 2, and so forth. Now, if we want to have a card have a single number that will represent a combination of the suit and the value, how are we going to compute this number? We need to have the number be unique for its card, and also we need to have a way that from that particular number we can determine the suit and the card value. One way we can do that is to say that a card as a single int will be represented as the number suit times 13 plus the value. Alternatively, same logic, we could have said that it would be value times 4 plus the suit. In this way, every card will be a value in the range 0 to 51 inclusive, and then if we want the suit of the card, we will divide that int with 13. The result of the int division will give us the suit. The mod of that will give us the value. The remainder of the division will give us the value of the card. And this is one way that we can represent cards. Now, how do we represent the whole deck of cards? We can use an int array that will have 52 locations, since we said that we can represent every card, any card, with a number between 0 to 51. The locations will initially be those values, those card values, so the deck of I will be equal to I for all of the indices of the array. This has the nice feature that initially the deck is sorted by suits and then by value. And also initially all the cards are available to be drawn. Now, what should happen if we draw a card? How should we change the representation of the deck? If we choose a card at random, then we should swap this chosen card with the last card in the deck. And we should reduce this counter that we keep, how many cards are available, by 1. By this swapping, we don't really have to modify our array massively. The last feature that we said that we want our deck of cards to have will be the ability to shuffle it. Now, shuffling would mean that we just set all of the available cards back to 52. Here is a figure, a picture that will help us understand better what we actually mean with this kind of representation of a deck. So we will have a deck array, so a reference to an array of int, and then it will have values from 0 to 51 representing the different cards of the deck. And initially the size of the deck is 52, so the available cards at the deck are 52. If we want to draw a card at random, we are going to use the next int method from the random class, as we have seen in a previous example. And we are going to use the next int method that takes a bound as a parameter. And that bound means that the random integer that the method will return to us will not be greater than size. So we use the size of this deck as this bound, and suppose, for example, that the random number that is returned is 5. What we're going to do now, remember that 5 is actually the 6 of the hearts, is swap the card at position 5 of the array with the last card, which is 51, the king of the clubs. And we also need to make sure that we decrement the size by 1, so that we can no longer draw the last card of the deck. As you can see, we just made this swap. So now position 5 of the array has the value 51, position 51 of the array has the value 5, and the size is 51, which means that we can no longer draw the card 5. Try implementing this, the solution to this problem, and then compare it with the solution that is available at the website that you see. Even if you do not try to implement a solution, which is strongly recommended, I still encourage you to go over the code that is provided at that link and make sure that you understand what it does.